All right, so here we go today. We're talking about permutations and combinations. So basics that we need to cover that we have already talked about. Fundamental counting principle. If you want to know how many ways a decision can be made, you can multiply the number of choices for the first decision times the number of choices in the second decision and get the total number of options. For example, if a shirt can be purchased in 4 sizes and that same shirt can be made in 3 colors, 4 times 3 would tell you there are actually 12 ways that shirt can be ordered, 4 sizes times 3 colors. We have a series of examples here. We've got the typical ice cream cone sizes times flavors times toppings gives us the total number of ways we could order an ice cream. License plates, and this is what I mentioned in one of the previous videos. If you have 3 letters, there are 26 letters in the alphabet, times 4 digits, 10 digits, 10 digits, 10 digits, 10 digits. There are actually 175,760,000 ways that a license plate can be made in this format. Now just think, you could have a license plate that's only letters, you could have a license plate that's only digits. There are plenty of other ways to do this as well. And there's even some symbols like the dash that you could add in there. So lots of choices. You do have to remove some of those choices because they've determined to be either inappropriate or they're ones that are reserved for, say, government license plates, things like that. Nick's science test has a section with 12 true or false questions. How many different ways can he answer? So every one of those questions has 2 options. So the first question is true or false, right? 2 options. The second question is true or false. So this is really every question 2 times 2 times 2 times 2, or 2 to the 12th. To enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So it is a 4-digit code, meaning that there are 4 spots that you have to enter a digit. And there are 10 digits times 10 digits times 10 digits times 10 digits, or you can simplify it as 10 to the 4th. Now, factorials are when you have a number and it's the product of all the naturals from the one that you're on down to 1. So n factorial might be 9 factorial. This is not 9. No one's going to scream it emphatically because there's an exclamation point. That exclamation point is read factorial. So 9 factorial means 9 multiplied by every natural number down to 1. Now, on your graphing calculators, you can do this by typing in the number 9, and then you press math, and you go to the right, and that's the one for probability. And you would go down here to option 4, the exclamation point. You're asking the calculator to do 9 factorial, which is 9 times every number down to 1, and you would get 362,800, the same as we had on the paper. You'll also notice that 0 factorial is on my screen. 0 factorial is worth 1. It's also on the paper. That is like a special, exception to the rule because factorials are supposed to be only down to the number 1. And so anytime you see 0 factorial, it is worth 1. That comes into play a little bit later. There's also times where you might have something like a factorial over a factorial. So 17 factorial over 11 factorial, you're going to have some repeats in there. If I do a shorter or smaller one, like for example, 5 factorial over 3 factorial, you would have 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1. And you'll notice that a lot of them end up getting canceled, and you just have the 5 times 4, which is 20. So this one, if you were going to do this one out, you could have 17 times 16 times 15 times 14 times 13 times 12, and then everything below that would be canceled by the denominator 11 factorial, and just this part would give you the answer that's there. So you can use factorials and simplify factorials to some extent. Now, permutations. A permutation is an arrangement or lineup of objects in which order matters. So that's going to be the most important thing when we're determining if something is a permutation or not. Does order matter? In permutations, order matters. So there is a formula to it, NPR. N is going to be the total number of objects available. So if you want to make yourself like a little cheat over here, the N is the total. The R is the number of objects used in the arrangement. So number used. So NPR, you're going to do N factorial on top. And then the bottom, you're going to do N take away R factorial. So it's the difference between the total and the number that you're using factorial. Important note here, NPN, if you have 6 items and you're choosing all 6 of them, it's just N factorial. So nice little shortcut for that one. And I'll explain it in a minute why that works. So 8p8 equals 8 factorial. And you're like, great, I can type that into the graphing calculator. Dinosaur, there's no letters repeated. It's 8 unique letters, and I want to arrange all of the letters. So I want to arrange a total of 8 letters into a total of 8 positions. So what that would be if we use the formula would be 8 factorial over 8 minus 8 factorial. And we just said that 8 minus 8, which is 0, that 0 factorial is worth 1. So this is really 8 factorial over 1, or just 8 factorial. So that's why we consider it a shortcut. 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So 7 students total, that's your numerator, 7 factorial, over 7 minus 3 factorial, which is the difference between the two numbers, or 4 factorial. And you'll notice how many of these get simplified, and you just end up doing the 7 times 6 times 5. Now, why is that happening? You're actually filling 3 positions, right? You're filling first, second, and third place. So if we just look at it as first, second, and third place, how many kids could come in first? Well, there's 7 students who could come in first. So let's say Joey comes in first place. Now there are 6 students left who could come in second place, and 5 students left who could come in third place. It acts kind of like the counting principle when we were doing probability, and it was without replacement. Once Joey gets first place, he can't get second place. So there's only 6 people left to potentially get second place, and so on. All right, so the next one, still a permutation because order matters, right? First, second, third place, order matters. Melanie is taking 4 classes, American History, Algebra 2, AP, English, and Chem. How many ways can these 4 classes be arranged in her schedule? So she has 4 classes going into 4 spots in her schedule. That's 4 factorial, or just 24. Does the order matter? Yes, because we were talking about arranging them on her schedule. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? So order matters. 16 total to choose from. We're filling 9 positions. 16 factorial over the 16 minus 9. So we would find the difference between 16 and 9, which is 7 factorial. The other way we can look at this is we can think about simplifying, right? 16 factorial over the 7 factorial. We would have 16, 15, 14, 13, 12, 11, 10, 9, 8, all in the top. And then the 7 factorial from then on would simplify with the 7 factorial on the bottom. There are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative and alternate? So here's where the order comes in. Are you the representative, or are you the alternate? Wow. So there is a difference, right? If I get elected representative, it's kind of like coming in first place, and getting elected alternate is kind of like coming in second place. So I'm really filling 2 positions. Order matters. And I've got 28 kids to choose from for representative. If Melanie gets picked for representative, there are 27 kids left who could get picked for alternate. Here, you've got 28 factorial, basically over 26 factorial. So everything from 26 down gets canceled, which is why you're left with only 28 and 27. Permutations with repetition. How many different 10-letter arrangements are possible using the letters in the word automobile? Now, they're pointing out here that the O's are repeated. There's 2 of the same letter. So you can do 10 factorial, right? You've got 10 letters. You're rearranging all 10 letters in 10 spots. But if you divide by 2 factorial, that gets rid of that repeated letter, because if I put the O here and the second O here, that's not a new permutation. How many different 9-letter arrangements are possible using the letters in the word disappear? There's a double P and a double A. So you'll notice this time there's two factorials that we have to divide out to get rid of any of the repeats. All right, so now we've got combinations. Combinations is a group of objects in which order does not matter. So that combination lock you've been using your whole life, or the combination lock you've seen your whole life, really not using them a lot of your life at this point. It's really actually called a permutation lock, because in your combination lock, the order matters, right? What number do you put in first? What number do you put in second? What number do you put in third? That would be a permutation lock. The one that I have here at my house for my house key is a combination lock, because it has the numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has all of these numbers on it, and you just like push the numbers, and it doesn't matter what order you push them in. As long as you push the right 3 buttons, it opens the lock. So what's interesting is that that would actually be a combination lock because it doesn't matter what order I push the three numbers as long as I push all three of them. So combinations, a little bit different. You start out with the same numerator, right? It's still the total factorial goes on the top. R is the number of objects used for the arrangement. So 16 items total. Natalie has 16 close friends. So 16 is your total. How many ways can she choose? 5 to be bridesmaids at her wedding. So she's choosing 5 out of 16. Now, order doesn't matter because she's just choosing a group of 5, like which 5 people are going to be in the wedding. She's not talking about the order they're walking down the aisle. She's not talking about the order that they're standing at the altar. She's just choosing a group of 5 girls. So the denominator is 5 factorial times the difference factorial. And what you're doing here, this extra little piece, you're getting rid of the duplicates. So if I had a group of 5 friends and I just changed the order of their names, that wouldn't be a new group of 5 friends. So I have to get rid of a bunch of repeats. That's really the only difference with combinations, is that you have to get rid of the repeats because the change in order does not actually give you a new group. So here we did 16 factorial over 5 factorial times 16 minus 5 factorial. We can do all of this on the graphing calculator. You want to be careful with your parentheses. So your numerator is 16 factorial divided by, now notice I put it in parentheses, which might be a little overkill, but I try to be really careful anytime I'm doing something with division and multiple steps on a graphing calculator. I'm going to do a second set of parentheses. I'm going to put the 5 factorial and then parentheses around the 16 minus 5 factorial. You could, at this one, you could actually just do the 16 minus 5, which might make your life a little easier if you did that in your head. 11 factorial. Close it and close the first set and then hit enter. And you're going to get that 4,368 that we had on the paper. So you can do, once you've written down this piece, you can do the rest on the calculator to get your final answer. But I would definitely be looking for, did you choose combination? Is it, a group of 5 out of 16? Which numbers did you put where in the numerator and the denominator? And then your final answer. So this would be 4,368 groups of bridesmaids. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So if you're an attendee, I don't care if my name was first in the list or my name was 7th in the list, as long as my name is on the list. So he's choosing from 24 kids. He can bring only 8 to his party. So 24 is the total factorial over the 8 factorial, which is going to get rid of my duplicates, right? If Kyle is choosing Joseph to be first on the list versus Joseph being second on the list, it doesn't matter. That's a duplicate. 24 take away 8 is my n take away r factorial. That was the same part from permutations. And then I can use the calculator to get my answer. Abby's adopting kittens from a pet store. If there are 18 kittens, how many ways can she choose? 2. So if she chooses, the calico, and then she chooses the gray kitten with the white circle around its nose, that's the same kittens to take home as the gray kitten with the white circle around its nose and the calico. I don't care what order she picks them up out of the box. She's picking 2 out of 18, and you have to get rid of those duplicates. There are 12 employees at the sub shop. How many ways can the manager choose? 4 for the Sunday evening shift. Doesn't matter if he puts my name first on the list, third on the list, second on the list, or fourth on the list. If I'm on the evening shift, I'm on the evening shift. Get rid of those duplicates. So 12 total people to choose from, and he's filling 4 positions. There are 85 players on the football team. How many ways can the coach choose 3 to represent the team at the coin toss? So if the football team is picking Arrow and Nathan and Kyle to be the 3 representatives, that's the same as Kyle and Nathan and Arrow. That's the same as Kyle and Arrow and Nathan. That's the same as Nathan and Arrow and Kyle. That's this part here where I'm getting rid of all the duplicates. There are 6 total ways to group those 3 kids, and it's the same 3 kids in the group. So that's really the main difference in a combination when order doesn't matter, is that you have to get rid of the duplicates.